Hey YouTube, thanks for tuning in. That's part 2 of my videos about the Furitek brushless conversion kit for the SCX24 with the new Komodo motor, the Outrunner motor, and the Furitek Lizard ESCs. Find the link to part 1 and all the explanations about measurements in the description. In this video, I will measure the RPMs of the Furitek Komodo motor and also the Surpass 1400 kV Outrunner using the Furitek Lizard ESC, and I will measure RPMs of the Furitek Komodo motor using a normal cheap brushless bash ESC, and I will show all the results to you in graphs and explain what we see, the huge RPM jump in the beginning and throttle response and things like this. And in part 3, upcoming soon, I will change the settings in the Lizard ESC and measure RPMs again, and we will see how changing the settings of the ESC will affect the RPM throttle response of the Furitek Komodo motor, and if we can get rid of this huge RPM jump in the beginning. So let's start the RPM tests with the Furitek Komodo motor, Furitek Lizard ESC, and totally stock settings, so only forward reverse 100%, and that's the setup. I hope you can see at least a little bit. Here's the RPM meter, the motor, my FlySky Noble, and first we will check the maximum RPM forward and reverse with a full battery, of course, 4.20 each cell. So the motor does have 1400 kV. What should we expect? 8.4 by 1400 should be 8000, 11,200.4. So about 12,000 RPM should be the maximum, and if timing is 0, exactly should be the maximum in forward and reverse. We will see if that's true. Works. And I have to place the meter that way, and now full speed forward. What is it? 12,064. Hold 12,058 now, so super cool. Exactly what could be expected from a 1400 kV motor, and 8.4 volts. And now let's try reverse. 12,280. Now 12,270. Hope you can see it on camera. So awesome, exactly what should have been expected by this thumbs up. And now I will start measuring RPMs by going to trim negative, but first positive. What is forward? 60 steps in 2 points each step, so 2, 4, 6, 8, and we will see when it starts and when the RPM jump comes. 2, 4, 6, 24, 26, 28, 30. It starts at 30 with 35.6, 36 RPMs. Let's go back. 28 still runs. 26, no, 22, 24, 26, 28, 30, 36 RPM, and if I go back, steps back, 28, still runs, 36 RPM, 24, still runs, 22, stops. So 24 and 26 work if we're going from higher RPMs back, and 28, it starts at 30, 36 RPM, 32, nearly no change, 38 RPM, 34, 39 RPM, 40 RPM, 56, 85 RPM, 58, 94 RPM, 60, 105 RPM, and 62, the jump to 1053 RPM now. And going back to 60, 58, 56, 58, 90 RPM, 60, 106 RPM, 62, 1044, 1024, 1030. So exactly here is this huge RPM step between 60, 58, 60, 62, 1046, 1050, 60. If going back it stays fast, 976 if I go back, 56 slow, 60, 100, 62, 1040, 64, 1100, 66, 1215, 118, 3000, 2995, and 120, 60 steps, 3020. So awesome results in my opinion. And now let's do the same in reverse. -2, -4, -32, -34. Cocking does not start. 34 cocking. -36, it starts smoothly and seems to be a little bit faster. 59 RPMs. Let's go back. -36, -40. Oh, I went faster. 36, -34, it stops. -36, it starts with 58. Stops 34, 36, 59 now. Okay. 38, 64, 40, 70, 46, 100, 48, 1054, 1053. So 48, 46, 44 slow, 46 now still slow, 104, 102, 48, 1037, 14, 22. So 10 times increase, 44, 46, 48, 1040, 50, 1159, 1160, 52, 1326, 116, 4417, minus 118, 4450, and minus 120, full minus, full reverse, 4482.
Center point.
Awesome. So, and these are now the results of the RPM measurements of the Komodo motor with the Lizard ESC stock settings shown in a graph. Here on the y-axis you see the RPMs up to 4500, and on the x-axis you see 0 trim steps in the center and the 60 trim steps from 0 to 120 in forward direction and in reverse direction. And what's what we are so interested in? Those are those tiny areas. This is this super slow crawl behavior we see and the motor and the ESCs can provide. That's what everyone's so crazy about. And here you see the immediate abrupt RPM jump from around 100 to around 1000. So let's see this area a little bit more detailed here. And here you can see 0 trim steps, and in forward direction at 28 still 0, and at 30 the motor starts to spin in forward direction. If I go back, those dotted lines here, it runs down to 24 or 22, and this is the super smooth increase of RPM from around 36 was the start in forward to around 90-100, and this within one trim step, one click from 60 to 62 here is the huge step, this jump from 100 to 1000, around 100 to 1000. So that's the jump we feel and nobody really likes. Let's go to the total graph again. You see it seems in reverse direction RPM at 120 are much higher already than in forward direction, and also in reverse direction the lowest RPM, it starts at 34, I guess it was, trim steps, so 17 steps minus, is also significantly higher than it was in forward direction. Again, let's go to the larger graph again, and here we have 100, that's I guess 59, and here it started at 37. That's what we all love in those ESCs. That's what we do not like so much, this totally abrupt RPM increase within one click from here 100 to more than 1000 in reverse, and nearly exactly the same in forward direction. And now let's also measure the RPMs of the Surpass Hobby 1400 kV Outrunner and then compare those two motors. So now let's test the Surpass Hobby 1400 kV Outrunner, again with a freshly charged full battery, 4.2 volt each cell. (1400 kV) also. Settings are the same, reverse 100%, everything else stock settings in the ESC. So Let's check max RPM. Maximum RPM should be about the same. And it is nearly a little bit less, 11,300 forward. And now let's check reverse. $11,560, so little lower maximum RPM than the Furitek Komodo. And now let's start with forward trim.
Center point.
2, 4, 6, 30, 32. Starts at 32 nicely. 37 rounds per minute. If I go back to 30, still runs, still 37 rounds per minute. 28, still runs 36 rounds per minute. 26 still runs. If going back, 36 rounds per minute. And now it stopped at 24, so 26, 28, 30, starts again 30, 36 rounds per minute, 32, 38 rounds per minute, 34, 39 rounds per minute, 58, 89.7, 90 rounds per minute, 60, 100 rounds per minute, 101, 100, 100.4, 100.6. And now here's the big jump. Go back to 58, 60, 60, 100, 100.5, and 62, the big jump to 940 rounds per minute. 64, 1021, 116, 2777, 80, 77, 80, 118, 2825, and finally 120, 2843.
Center point.
And now let's check in reverse direction. Minus 2, 4, 6, minus 30, minus 32, 34, minus 36. It starts with 61 rounds per minute. Minus 34, it stops. Minus 36, it starts again with now 61 rounds per minute, and 34 stops again, so no back step in reverse. 36, 61 rounds per minute, minus 38, 67, 79, 44, 93, 46, 100. Here's already the jump at 44, 46, 920, 920 about. So 44, slow, 91 rounds per minute, and 46. Now it's again slow, 104, and it starts during, so 44, 90, about 90, and 46. Starts slow, but then 893 now, 48, 900, 1000, 50, 1090, 116, 4146, minus 118, 4183, minus 120, 4208.
Center point.
So these are now the results of the Surpass 1400 kV motor. You see the graph looks very similar to the Komodo motor results. Reverse 4000 and a little bit maximum RPM, and forward only about 2000, nearly 3000. That's the area we are super interested in. Again, looks very similar. Let's take a closer look to this area again. In forward it starts at 30, you can see here, and I can go backwards to 24 I guess here, and very smooth increase up to nearly 100 RPMs, and 60 is the border, 60 still smooth running, and then from 60 to 62 the huge RPM jump up to nearly 1950, and in reverse it starts at 36 and only a very short area, and a big RPM jump comes from 54 to 56, again up to more than 900 RPMs. But more interesting, let's compare the results of the Surpass 1400 to the results of the Komodo. And here we can see both curves, and you see they are nearly equal in the low RPM area. The red lines, the Komodo does have a little bit higher RPMs at minus 120 and plus 120. The curves, the shape of the curves is super similar, and we should check this area little more close. Here enlarged the interesting area, 0 plus 60 in both. Blue line the Surpass motor, red line above the Komodo motor. 60 is the last step where we have this smooth increase, and from 60 to 62 the RPM jump from less than 100 up to 900 something and 1000 something, 900 something in the Surpass, 1000 something in the Komodo motor, and both start at 30. In both, in forward direction I can go backward to 26, 24, and both have a very smooth and nice increase of the RPMs at the very low RPM area up to what was it, 90 or something, and in reverse direction, same picture nearly. Both start at 36, flat curve, but by far not as flat as in forward direction, and higher RPMs, around 60, up to the area where the jump comes. The Surpass motor 44 to 46, and the Komodo, the Furitek Komodo motor 46 to 48, and here again we have this huge jump in the Surpass motor from around 100 to 900 something, and in the Komodo motor to over 1000. So those motors and their results look very, very similar. So you saw the results of those two outrunners, the 1400 kV Surpass and the Furitek Komodo 1400 kV are very, very similar. The low speed behavior is nearly exactly the same. The Furitek seems to have a slightly higher maximum RPM, but this can only be this motor, and the next would have a little bit less, I don't know. What else? The shaft is 3 mm. Furitek Komodo does have a flat side, while the Surpass 1400 does have a round shaft. The housing is for a car probably nicer in the Furitek Komodo. You see more protection than in the more open Surpass 1400 kV. People tell the Komodo is even stronger than the Surpass. I can't really prove this. I won't make torque measurements of both. You saw this maybe when I tested the 550 motors, the brushed ones, torque tests, but motor smoked. I don't want to destroy those. Build quality seems very, very good in both. We can open them. They are only secured by circlips and shims. So let's take a look inside. What else? Weight is probably nearly about the same. But in the Surpass 1400, it comes with 3 mm bullet connectors, so you will need this adapter you will get with the Furitek ESCs. And of course, because of this, it will probably be a little bit heavier, while the Furitek Komodo comes with JST PH 3-pin plug, fits directly to the ESC. The weight, come on, nearly exactly 30 grams, 29.7. And the Surpass, probably a little bit heavier. Yes, 33 grams. Probably because of the plugs. I won't remove them now. So how to confirm which one is better? Of course, the Komodo seems to be a little bit nicer because it's especially made for the SCX24. But let's take a look inside how the build quality is. Maybe we can see the magnets. The Komodo could be better if it would have better magnets, probably. So I will take the clips off and then we can take a look inside. So it's not difficult to open those motors. You simply will have to remove the clips. Both come with a similar clips and both come with two shims. The golden or copper colored one are from the Surpass, the silver ones are from the Komodo motor. And then simply take off the bell. It's only held by the magnets. And here you can see the starters and the magnets of the Surpass motor. A little bit of trim weight. Seems to be really, really nicely built. And let's do the same thing with the Komodo. Even easier. So also super nicely built. Seems to be glued with epoxy. And this one there seems to be less epoxy. So here Surpass versus Komodo seems to be the same number of magnets, is it? 14 magnets and 3, 6, 9, 12 poles in the Komodo and 3, 6, 12 poles also in the Surpass. Really hard to say which one should be better. I do have a very simple magnet field measuring tool, but of course that's not the proper way of measuring. But maybe if the Furitek magnets are stronger, let's check. Unshielded for sure. Horrible. Yes, it's afraid. Come on. So let's, what do we measure here? Light. What's that? Micro Tesla. About 0.25. But yes, some danger. And in the Surpass motor, what do we measure here? 0.25 also. So, okay, 0.25 microteslas in both. So I honestly doubt that the Furitek motor is really stronger, as someone told in a video, than the Surpass motor. I think they are nearly exactly the same. Okay, differ a little bit in maximum RPMs, but to answer this question, if that's true in all motors, I would have to buy 5 or 10 of both and check if there's any variance. So maybe the Furitek is really a little bit stronger, maybe not. I can't confirm this. Both look awesome. The Furitek for sure is better for the SCX24 because of the plugs, and for the pinion because it does have a flat spot, a flat side on the shaft, and a little bit better protected. However, I wouldn't use those motors, neither this nor that, really outside or under wet conditions or very dusty dirt, dust, sand. For sure not good for those motors. So okay, winner Komodo, but if it's really stronger, I don't know. And finally, let's test the Komodo with a super simple, super cheap brushless ESC for bashers and compare how the results with such an ESC are compared to those awesome Furitek ESC with the awesome low speed behavior. And now let's test the Furitek Komodo 1400 kV with the normal super cheap basher 20 amp brushless ESC and see what's the difference to the awesome Furitek ESCs. Again, of course, fully charged battery, 4.20 volts per cell. And first let's check maximum RPM. Forward, wow, 1300, 1307 in forward direction. And in reverse, 1300, 12,970. And now let's start. 2, 4, 6, 8, 10. It cocks already at 10. Forward trim steps, so 5 steps. 8, 10, cocking, starts a little bit. 12, still cocking. Seems to be something about 400 RPM, but cocking. And 14, it starts to run. 619. 16, 619 still. 18, 1138. 20, no change, so seems to take only every second step. 22, 1666. 24, no change. 189,730.
Center point.
And now let's go in reverse direction. 2, 4, 6. Eight, 10, 12, 14, 16, 18, 20, minus 22, 24, 26, minus 28, minus 30, minus 32, minus 34 starts cocking, 190, 170, minus 36 still cocking, minus 38 starts, 623, 24 is the lowest, minus 40 no change, minus 42, 1339, 44 no change, 118, 8610, and minus 120, 8777.
Center point.
So that's the graph of the Furitek Komodo 1400 kV outrunner motor with this normal super cheap brushless ESC. What you can see here, it cocks, starts at plus 14, and in reverse direction it does only start with minus 34, I guess, before cocking 2. And what you can see nicely here, it seems to take only every second step. So this step-like increase here shows this. Much higher RPMs. Higher RPMs in forward direction, nearly 9,000. In reverse direction, 8,400 around. And after starting, there is a smooth increase. So there are these steps, only every second step of the trims made the throttle increase, but the curve does have a smooth shape and no huge increase step as with the Lizard ESC. Same in reverse direction. But what's much more interesting than this, let's compare this result of the Komodo with the normal ESC with the Komodo with the Furitek Lizard ESC here in red. So that's the graph you did already see, only with a different y-axis. So that's this graph with the Komodo 1400 with the Lizard ESC, but here the y-axis scaling is only up to about 4500, while here it's up to 9000. Here we have the RPM jumps at 60 and minus 46, 48 in a very flat curve, and those are the areas we are so interested in. And in the normal ESC we have a little bit of cogging in the beginning. That's what no one likes, and that's why it's not really sufficient, adequate for a crawler. And then we have a steep incline of that curve, and let's check this area more exact. Here again only up to minus 60 and plus 70, and you see with the normal ESC we have this cogging, and then super steep incline of RPM. And in the Komodo with the Furitek Lizard ESC, as you have already seen, starts a little bit later, 30, super low RPMs. Here we are less than 100, and what you can see here, that's the first step in the normal ESC where we have a smooth running. That's 600 already, 600 RPM, and the Lizard gives us about 20 steps up to only 90 RPMs. This jump is the downside of the Lizard ESC, but I hope this graph lets you understand why a normal brushless ESC is not really super cool for slow crawling, super steep incline. And here you can bash, and here we have the super slow RPMs for the super slow crawl, then the jump, and then increase of throttle curve is not as steep as in the normal ESC. The normal ESC showed about 13,000 RPMs maximum, while the Lizard ESC with the same motor only about 12,000, so that's also an interesting point. So part 2 of this video is already again way too long. I hope you liked the results so far. As I've shown in the graph, 13,000 RPM, 12,000 RPM, 11,500 RPM maximum. That's not what we wanted to see. The low speed behavior, that's what we are interested in. And therefore, I also changed the parameters in the Furitek app. So super interesting results. If you did like this video and the results and the measurements, you will even like the next part 3 of this video series more, because I promise that's super interesting. And yes, we can change the parameters with the app and it will affect low speed behavior, and yeah, you will see. Stay tuned for this part 3 video. It will be up soon. I did already do the measurements and the recordings. And so far, thanks for watching part 2. See you in the next video. I'll be back.